Hello everyone. First of all, I would like to thank the organizers of MITAB Symposium for inviting me to present my research work here. My name is Subhash Kumar. I am working as a researcher at International Energy Research Centre, Tyndall National Institute in Cork, Ireland. Today I am going to present my work, a multi-regional model to assess the effectiveness of emission reduction policies and energy security issues in Southeast Asia with my colleague Patrick Leon and Professor Brian Norton. The outline of my presentation is introduction and research questions, methodology and modeling framework, then some scenario development and result and discussions, and to the end some concluding remarks. So before going to the actual modeling work, I would just like to give some overview of the energy and environmental situation in Southeast Asian countries. So according to the World Bank report, Southeast Asia is contributed about 5.6% of total global energy emissions in 2018, and the only 4 countries like Indonesia, Thailand, Malaysia and Vietnam contributed more than 80% of the CO2 emission in the region. Because Southeast Asia heavily depends on the fossil fuel power generation and coal is the dominant source, which installed capacity is about 89.5 gigawatt in 2022, which is about 31% of total installed capacity in the region. Also, Southeast Asia is a net importer of energy from different countries. It imports about 40% of its energy needs. Because of the shortage of indigenous supply and pressure to reduce the energy GHG emissions, it is urgently needed to diversify its energy supply. The renewable energy adoption is expected solution for the growing need of demand of energy in the Southeast Asia region. At the moment, the renewable energy just contribute about 13.9% of total energy mix, and the target is to achieve it about 23% by 2025. Because of the COP26 net zero emission by 2050 and keep the maximum temperature rise up to 1.5 degrees C, there is an urgent need to reduce the GHG emissions globally as well as in Southeast Asian region in the next decades. So there is not a single solution that can tackle with the energy security issues and global climate change issues. So we have to diversify it. If you see the diagram, there is coal and gas, which are two most installed capacity in the region, and that account for about 62.5% of total energy production. So in literature there are many modeling work has been done for Southeast Asia region, and all of these studies just considered the renewable energy implementation, and energy efficiency is just ignored in most of the studies. Only some of the studies individually consider for energy efficiency, but they have not considered the integral part of renewable energy and low carbon technologies. In the present study, we are just going to implement the renewable energy and energy efficiency measures by considering the low carbon technologies. A multi-region model is developed by considering each country in the region as a entity, and in this study we have just ignored the Laos and Myanmar because we don't have reliable input data from these countries. So the modeling work just give the answer to the following questions: that how do government policies affect the future electricity demand and generation, and also the power plant capacities, what kind of renewable is more suitable for which country, what is the cost of renewable implementation, and what is the least cost scenarios for the renewable energy deployment, and what is the overall cost, what are the effect of energy efficiency measures in energy demand and supply mix, and how much GHG emissions can be reduced with a different combination of low carbon technologies. For that, we are just developed a model. This is called long range energy alternative planning model. This is an energy and environmental simulation model that can reflect the current situation and develop forecasts under the given conditions. And this model is developed by Stockholm Environmental Institute. This model has 4 modules: demand, transformation, environment, and evaluation. In this work, we are using the capability of the LEAP to calculate the optimal expansion and dispatch of power plants. The least cost system can optimally be calculated subject to different constants, and these constants can be annual level of emission, or capacity constants, or activity constants, or some user defined constants as well. So the LEAP model scenario capabilities is used here to explore the different optimal solution under different sets of input assumptions. This is a mathematical framework where it calculates the objective function to minimize the total discounted system cost for each year and for each technology, subject to different constants. The constants are the production constant, that is the production should always be greater than demand and consumptions, then capacity constants, activity constants, and many other constants has also been used. And this model actually developed with linear programming and with a system. This is called osmosis, which is developed by a consortium and integrated with LEAP energy system model. So we have developed the scenarios. Some assumptions are given here. That is time horizon we have taken as 2020 to 2050. 2015 is taken as a base year. The discount rate is 5% according to the bank interest rates, and transmission and distribution losses are also considered as average 15.6%, because different countries in the region have different transmission and distribution losses. So we have taken the average from all of these countries. And we also consider some key assumptions, that is population, per capita income, GDP, growth rate, and number and size of the household to project the energy demand to use in this model. So we have developed 6 scenarios by considering energy efficiency, renewable energy, and various combination of technologies. The first scenario is the business as usual scenario or reference scenario. This is a status quo and assumes no changes in the policy and energy production from 2020 to 2050. Energy efficiency scenario is the second scenario that considers the reduction of energy demand according to the national goals. If the data is not available for a particular country, we have considered the 10% average for the region. Renewable energy is the third scenario, which consider the extension of sharing the renewable energy according to the national goals. And fourth scenario is the full potential of renewable can be used with the full technical potential available in the region. And the last 2 scenarios are combination of energy efficiency and renewable energy scenarios. For this scenario development, we have used some national targets about the energy efficiency and renewable energy for different countries. We have also considered the emission reduction targets by 2030, and also some targets we have also considered for 2050 as well for these countries. If you see, just like for example, if you take the Indonesia, they have committed to reduce the GHG emission by 29% until 2030, and they have also committed to reduce their consumption in all economic sectors on the average it is 13%. So all other countries are also fix some target for the energy efficiency and renewable energy and to reduce the GHG emissions. So for the as an input parameter, we have used some techno-econometric parameters and considering the power generation technology. This is coal, natural gas, large hydro, nuclear, solar, wind, a small hydro, and geothermal. And we have taken the start year from 2020, their lifetimes of the different technologies, power plant efficiencies, and availability fraction as the technological parameters. And for the economic parameters, we have considered the investment cost, fixed and operation maintenance cost, variable operation and maintenance cost for all of these technologies. So putting all these parameters in the model, we have run the model and we just find some results which I will just show in some slides. First of all, the energy demand. If we compare the energy demand in two scenarios, reference energy scenario and energy efficiency scenario, we can see that there is a substantial reduction in the energy efficiency scenario in the energy demand in 2050. For the reference energy scenario, the energy demand is 6,250 in 2050, while in the energy efficiency scenario, this reduces to 5,400 terawatt hour. So this is a 12% of energy demand reduction in the energy efficiency measures in 2050 compared to the reference energy scenario. If we see the installed capacity for all of the scenario, there is a substantial reduction in the installed capacity. In the business as usual scenario in 2050, we need at least install capacity of around 1400 gigawatt for the region, Southeast Asian region. If we consider the energy efficiency scenario, there is a 1200, so the reduction is about 200 gigawatt less installation we need in 2050. Similar thing happen if we consider the energy efficiency and combined with the renewable energy scenarios. Even though the renewable energy has low efficiency, so we need to install the greater than the fossil fuel power plants capacities. But since we are implementing the energy efficiency along with the renewable, the installed capacity in 2050 is almost equal to the business as usual scenario for all scenarios. If we consider only renewable energy and full potential of renewable energy, this is the highest installed capacity, so we need more and more investment to install the renewable energy. But if we consider the energy efficiency along with renewable energy, this is a very viable, and this also reduces the installation of renewable energy power plants. If we talk about the GHG emission in the region between 2020 to 2050, we can see for all of the countries and in all of the scenario. So in the business as usual scenario, as expected, it is the highest emission. And if we consider the energy efficiency plus full renewable energy potential, this is the lowest GHG emission. So in this way, we can say that the energy efficiency is a deciding factor and it can reduce a huge amount of GHG emissions if it is integrated with the renewable energy resources. In the second picture, if you can see here, there is different scenarios for different countries, and this is a total GHG emissions in the region in different scenarios. So you can say that energy efficiency plus full renewable energy implementation is the most effective scenario where a huge amount of GHG is reduced between the time period of 2020 to 2050. Similarly, if we go to estimate the net present value for different scenarios and for different countries, then we can see that the business as usual scenario in most of the alternative scenario has the low net present value compared to the business as usual scenario. That means all of the scenarios which has lower net present value is profitable compared to the business as usual scenarios. So only in some cases, just like if I see the Cambodia, the business as usual NPV is 9.72, but if I see all of the scenarios, they have less compared to the business as usual scenario, means all of the scenarios are profitable compared to the business as usual scenario. So we can say that any of the scenario can be implemented by the government according to the availability of finances, according to the availability of resources, renewable resources, and what is the measures of the energy efficiency. So this can also show that the cost effective solutions in different alternative scenarios. Now there is some concluding remark. We can say that the Southeast Asian countries follow a different approach how to cope up with the electricity demand and GHG emissions, but since there is no single solution to solve the energy security and climate change issues, for that we need integrated the renewable and energy efficiency measures along with low carbon technologies. And from the result, we have already seen that about 12% of energy consumption can be reduced by energy efficiency measures only in 2050 compared to reference energy scenario. If we talk about the net present value, all of the alternative scenario has net present value less than the business as usual scenario. That means all of these alternative scenarios are profitable compared to the reference scenario. The CO2 emission reduction actually reduce drastically in renewable energy scenario if we integrate with the energy efficiencies, and the whole result, if we conclude that the energy efficiency is an important factor for the GHG emission reduction as well as energy security at low cost, especially where in Southeast Asia most of the country has problem with the finances to invest in the new technologies for the energy transition immediately. So energy efficiency measure is very crucial parameter or very crucial technologies that can be implemented first, and then slowly go for the any other technologies to implement in the energy mix. So this is all about my presentation. Thank you so much, and my contact details are given here. You can contact me by email. So thank you so much.